So good afternoon to everybody. I can see the number of participants who are getting in the room, the virtual room. So I will wait for a few seconds in order to give you opportunity to all to get in, let me say, even virtually. Okay, I will use these minutes which are available for the introduction and also useful also for the people for getting the virtual room, for introduce a little bit what we are going to do today with this 11th webinar organized by the European Federation of Animal Science in conjunction with FIFANA, in order to explain a little bit what we are going to address a little bit in detail, but also have a look into the background of our commission and also what we are doing for the next meeting and so on. I will use a few slides in order to introduce a little bit story. As I said, this is the 11th webinar organized by European Federation of Animal Science in conjunction with FIFANA, which you know very well who they are. I will dedicate a slide later on. What we are going to talk today is about feeding the Green Deal, specialty feed ingredient contribution to environmental sustainability. We know very well who work in livestock and animal science and whatever, probably know that sustainability is an abused word, a key word, but very, very common in our talking and in each scenario that we consider today. Talking about livestock sustainability is extremely important as a keyword, as a topic, and from different point of view. However, what we are going to do today is, as a study commission in animal nutrition, the members are listed here, not so important, but of course, there is a group who manage the Nutrition Commission in the European Federation of Animal Science. I'm the president, but of course, I have a lot of people here who help me in organizing several things, starting from the annual conference that will be this year. I will show you later on in Portugal, but also activities like that we are going to do today. And is a small group, but extremely active and effective. So I have to thank them because every event that you can be involved about nutrition, it means that somebody has organized, defined the contents, the agenda, and whatever. So I have to thank them again. But today, as I said, there is another actor in this story, is FIFANA, which is the European Federation Association of Specialty Feed Ingredient and their mixture. And actually, they are a very good partner of ERP, because as I will show you later on, we are going to organize also other activities in the future, but also in the past. So we have a long tradition in terms of interaction, connection, networking, and so on. But the same with other organizations and associations like FIFAC and ATF and whatever. So we are extremely interactive. Why it is important? Because of course, ERP is a scientific association, but it is important for us to keep our connection with the industry, their association, and so on, in order to reinforce our link with the routine activities in the farm, about livestock, and so on. Well, as a Nutrition Commission, we usually organize about 6-8 sections per year in each annual meeting. These are the sections that we have organized last year in Davos. So I reported here just the title and few figures about the number of abstract presentation and so on. Nutrition is extremely important. We know very well this from different point of view, economic, due to the fact that nutrition has a big impact in terms of the cost of producing each food of animal origin, but also for the health of the animal and for several other aspects. What we are going to do for the next conference in Porto, you can see there is some noises. I ask all the people to mute the microphone, thanks. So I'm saying that the next meeting will be in Portugal, as you can see here the date, and in that occasion we are going to organize a few sections, few more compared to the last year. Yes, you have to consider this as a tentative program because we are working on the final program, and maybe one or two sections will be merged and so on. But for sure, what I would like to underline is that we are going to organize a further section in conjunction with FANA. We've only invited speakers in which we are going to address increasing animal resilience by nutrition. What's more? Well, 2 weeks later, we got the opportunity for participate to another conference, which is under the umbrella of ERP, which is the Energy and Protein Metabolism and Nutrition. This is a conference which which is organized every 2 years. And therefore it's not every years, and well, every 3 years, sorry. As you can see, we start in Germany, we move from Europe to US until also South of America and so on, and the next one will be in Granada in September, and I hope you will got the opportunity to join us. Of course, the abstract submission is closed, but the program is very, very interesting, quite dense, and also we got the opportunity for host the rank prize lecture in animal nutrition, which is an honor for us to host this prize in our conference. But we start with the program of today. As you can see, as always, the format is reported here. Our webinars are organized with 3 lectures or talk, and here are listed the invited speaker for today. We will move from the International Feed Industry Federation to University of Davis, US, and then to a company, a person from a DSM, therefore from a company. Well, also the topic addressed will be all connected with sustainability, but of course from different point of view. Well, shall we start with the first speaker? The first speaker of today is Philippe Becquet. He's an agronomist in terms of education with a specialization in animal nutrition. Since 1984, Philippe has been working for the feed industry, and all in different positions, from sales, marketing, technical support, and lately following regulatory aspects. Since 2010, Philippe has been active in different working groups on developing methodology for LCA, for livestock production system. The title of his presentation is Guideline on the Environmental Performance of Feed Additives in Livestock Supply Chain and their Practical Implementation. So, Philippe, the floor is yours, please.
Thank you. I will share my screen then. I hope you can see my screen.
Absolutely, perfectly.
Very good. So thank you for the introduction, Luciano, and thanks for the people for attending. So my presentation today will focus on the development of guidelines that we have made on total performance, and also what is the most important, I believe, how we want to implement them and how we implement them already. So today my speech will be done on behalf of IFIF, with the International Feed Industry Federation. I will give you some information about IFIF in a short moment. Then we will look at the development of the guidelines, particularly with a focus on feed additives. And then we will look at the implementation that we have done with this and the next steps. So IFIF is the International Feed Industry Federation, and we are the global voice for the industry. And in fact, we are promoting the work done by the feed industry along the food chain. And the objective we have is to provide sustainable, safe, nutritious, and affordable food, also looking at the growing world population and the need for impacting on climate change. Our members, we have 3 types of members, and we represent in total 80% of the animal feed production. The first part are national and regional associations, where FEFANA is one of a prominent member. And then we have some corporate members, and we have also the feed-related organization. So a mix of association looking at feed additive, feed, premixtures, also materials, all this is looking at. Globally, the feed industry represents occupies more than 1 billion people. We are producing protein and calories that are useful for humans, and that's what we at the end we produce. It's not only feed. We are also very conscious that the use of food has an impact on the safety of the use of feed. Sorry, has an impact on the safety of food. It's also a major cost of animal production, and in fact, we are innovating since many years in order to reduce the impact of our feed on the cost, but also on the environmental impact of animal production. And the key word for us is innovation. So we try to innovate ingredients, but also feed formulation. So it's not only looking at products, but also at how we manage all the products together, and to provide this to the farmers. We are organized on 3 pillars. One is sustainability. The other one is looking at regulatory and international standards, because our aim is also to make sure that regulations are put in place in order to have a fair working place. And then we also have a role in education and sharing of best practices. With regards to the regulatory developments, we are not alone. We are acting with a lot of people, particularly international intergovernmental organizations like Codex Alimentarius or FAO. And we are also in relation with private sectors, meaning that all the agri chain partners, so IDF was mentioned before, is one of the people with whom we work, IMS as well, the Meat Secretariat. And we are also working with our own members, of course. What we do mainly is that we work on the Codex Alimentarius, which is an organization that is regulated, or not regulated, but providing direction for future regulations. It's mainly related to feed safety and food safety. And then we work with FAO, OIE, and WHO, also in the sense of One Health, which is also part of a sustainability program. And with FAO, we have also a memorandum of understanding, and we work with them on different type of topics. So what we try is really to go to sustainability, considering many things, the social impact, the economic impact, the environmental impact, and also animal health and welfare, which are for us part of sustainability. And in fact, what we try to do is to produce more using less and even better at an affordable cost. So you see, we are looking at all the parameters of sustainability. We have in the sustainability a big area, which is the action area 1, where the objective is to measure and benchmark the feed impact. So that's what I will discuss today, is how do we measure what we do, and how do we make sure that what we do is going in the right direction. So, and that's the reason why we arrived to this development of guidelines for feed additives. In fact, IFI is being part of feed. We have been active on all the guidelines, but here the focus is mainly on the feed additive guidelines. So I will first speak of the LEAP, so the Livestock Environmental Assessment and Performance Program, which is a multi-stakeholder partnership with FAO, which has developed guidelines during the last 8 years. And in fact, the rationale was to say we can only improve what we measure. If you remember, we had a document from FAO early in this century indicating livestock long shadow. So it was measuring in a way a snapshot of the impact of animal production. But in fact, we didn't have a tool to really measure what we were doing, and also to try to see what could be the impact of the changes. So therefore, we developed this life cycle assessment approach for animal production. It was at the beginning mainly focused on greenhouse gases, but these LEAP guidelines have also been looking at the feed impact in terms not only on greenhouse gases, but all the impact. And also afterwards, the LEAP has developed guidance on nutrient flows, water use, and biodiversity, which were then added in terms of parameters and measurement to the greenhouse gases that were originally the objectives. The other objective was to make sure that we harmonize the system, because when you make a life cycle analysis assessment, you may use different methodology, you have choices to make, you have hypotheses to develop. And the objective of these guidelines were really to harmonize so that we can compare what we do from one time to another, and from one type of product to another type of product. So this need for harmonization was a key topic. In parallel, a little bit later, but it came in parallel, we have also the product environmental footprint category rules development by the European Union, where the objective was more focusing on Europe, but also looking at harmonization. So the objective was really to try to find ways to ensure that the communication on this product could be done in the same way. And in fact, what they established at the EU level is a general framework, which is called the PEF. And then they decided to go to specific guidelines for different type of products. We started with the first pilot phase, where some people decided to work on this. So to implement the generic document from the European Union into practical activities. So two groups worked on this in our sectors. There were other sectors covered, but two groups worked on it on our sector, the feed sector, and there we had a collaboration between FEFAC and FEFANA to develop the feed PEFCR, as we call it, which is used then to measure the impact of the feed from the cradle, so from the development and the production of raw materials up to the gate of the feed mill. And then we have the EDA, so the European Dairy Association, that was doing the same, but from the dairy product. And then they looked more from the farm to the end product sold to the consumers. And the objective also, at that time, it was just the origin of a system, but the objective was also to be able to communicate. And now with the Green Deal, you see that this communication is becoming key. So all the work done on the PEF guidelines in the past are now potentially finding their ways when we will be able to communicate on our products. Now, when you look at this, a lot of things were done on feed, and feed was considered in its generality, meaning that's composed of feed materials. So it's a ration of the animals, so either the complete feed for the monogastric animal, but also the complementary feed for the ruminant animals. But the feed additives were there, but not completely there, I would say. So we thought that there will be a need to also consider the feed additives, because they have two impacts on the environment. One impact is the manufacturing. When we manufacture the feed additives, whatever the manufacturing process is, you impact, you emit some of the things to the environment. But also we consider that it's also important that we consider the use, because with the use of the feed additive, you could mitigate emissions. So you could mitigate by many different ways. But whether you take an antioxidant that is preserving an oil to being wasted, up to the feed additive that you give to the animals to improve the performance, you have an impact anyway on the emission of the feed chain. So and the food chain as well when we look at the animals. So therefore, in parallel to the PEF CR and to the LEAP guidelines, the industry developed a project which was developed both by FIFANA and IFIF at that time, which is called the SFIS project. And you will see the results a bit later. Ermias will present the results of our work there. But this project was really to think about how do we consider the two different impacts. And we were looking at all the impacts, and in fact, the main impacts on which we saw an effect were the climate change with all the greenhouse gases, the methane emission, nitrous oxide, but also related to the use of certain feed material, the acidification and the eutrophication, mainly related to nitrogen and phosphorus. But these were in the original phase that we looked at everything, but in fact, these three factors were really hotspots of our activities. So the main impact we have are on this. And then coming back, so this was done in parallel. Now, how do we combine all this together? So in the PEF guidelines, there is a mention on the feed additive, because the PEF was mainly focusing on all the feed materials. So when I say feed materials, it's wheat, barley, soybean meal, rapeseed meal. But there was a small part on the other feed ingredients, and particularly the ones produced by other methodology or manufacturing processes, but just agricultural processes. And you see that the reference in the PEF is done to the LEAP. So this is a big link we have between the LEAP and the PEF on the feed additive side, is that the PEF did not develop specifically something for the feed additive, but referred to the LEAP guidelines that should be produced. So therefore, we were thinking about the feed additive. Now, if you look at the system today, as it is in the PEF, you have on one end the cradle to feed factory exit gate, which is the feed PEF CR, and the feed guidelines also for LEAP, where you measure the impact of the production of the feed up to the farm gate of a factory. Then you transport it and you go to the animal production. So if you measure the whole system and you have all the data regarding the composition of the feed and also the performance of the animal production system, you can calculate a cradle to consumer gate impact of a product. But then you do not evaluate mitigation options. So you will measure a snapshot of what is done today. But if you want to evaluate which mitigation option you could use in order to reduce the impact either of the feed production or of the animal production, we didn't have a tool to do that. So therefore, when we discussed that within the LEAP, we agreed that this LEAP guideline should cover the two aspects and should be able to help the people to make mitigation options and to evaluate the mitigation options. So the LEAP guidelines on feed additives were there developed and was published 2 years ago, if I remember correctly. And there we were looking at two aspects. One aspect was the manufacturing process of a feed additive. And then you see that there are different types of feed additives. So you have the feed additives which are produced by chemical synthesis. You have the ones which are covered by, I would say, processing of plants with extraction, animal product extraction as well. And you had also, how can I say, the fermentation processes, the mining processes. So all these processes have been evaluated in order to make sure that this was in line also with the LEAP guidelines on feed, where we were looking at agricultural product. So the idea we had there was to put into perspective the feed additives also with regards to the other feed ingredients, so that we have something harmonized as well. Harmonization is a keyword. And then this manufacturing process enables you to have an impact of your feed ingredient, being a feed additive in that case, of your feed ingredient when used into the feed. So it doesn't show anything about the impact. So we are mainly looking at this aspect here when we do that. So it's the manufacturing phase in red in the the slide here. Then we were looking also at the use phase. So what is going on the animal? And then the perspective we did is that we were using a baseline, which is the status of a farm at the time that you come in the farm. And then you see what could be the mitigation that the feed additive provides you. And then you look at the impact of the mitigation option on the animals. So looking mainly at this part there. So this is in green in the slide. So this covers potentially the compound feed production, where the use of feed additive may help you to modify the formula, so the composition of the feed. Just to give you an example, if we would use amino acid, we reduce normally the level of protein. If you reduce the level of protein in the diet, you are using less feed ingredients providing protein. And therefore, you will increase also the ingredients that are providing energy. And then you change the balance, the composition of the formula. And this can have, or have certainly, an effect on the environmental impact of the feed that is produced. You could also play the same game with phosphorus using phytase, for example. You will reduce the phosphorus content of the diet, use more of the phosphorus in the plants, and then be able to produce a feed which potentially less impact. The second impact we were looking at was the impact on the animal farming itself. That means improvement of performance, reduction of excretion, reduction of emissions like methane emission. So this was also looked at in this use phase. So again, in the use phase, we are evaluating mitigation options with a baseline and the impact. And then, of course, we look at the balance between the two. With regard to the manufacturing process, we have developed for each of the systems, so mining, plant extraction, chemical synthesis and fermentation, we have developed a system on how to measure and what to measure. So this is a figure that you will find in the LEAP guidelines. And there you see that we have the input and output all the time, and the different levels, the different part of the system. So all the feed chain, in that case, the feed ingredient chain is managed. As you see here for a plant product, you will have the plant cultivation, also the harvest, and then the use of the plant biomass, either by extraction or other type of things that you do with it. And then you go to the final product. So this is looking really at the cradle, so the feed, in that case of the plant production, to the production site exit gate of a feed additive. We didn't go so far as going to the entry gate of a feed mill because the feed additives are usually produced in very specific locations, and the feed mill can be either very close or very far away from this location. So this we kept outside, and it should be calculated when we make the LCA. It should be calculated to account for it. We also looked at different level of aggregation, meaning different level of details in the way we express the environmental footprint of the manufacturing of a feed additive. It's level 1 and level 2. So in level 1, we are, I would say, looking at the big things, and then at level 2, we are looking at the detail of the manufacturing process on the production site that will enable you to give the product. And there is a rule in the LEAP guidelines on how to manage the level 1 information and the level 2 information, depending on what you want to do. And when you look at this approach, although it may sound very difficult and complex compared to a feed ingredients, in fact, we have exactly the similar approach to other feed ingredient. So with this part on manufacturing, we are able to produce data to measure the impact of the manufacturing of feed ingredients. And this will go then to the farm gate, and in the farm, so not the farm gate, the feed mill gate, with adding the transport. And this will be contributing to the feed, total feed, exit gate value. So what is calculated by the PFCR before. Now, when we have the mitigation options, what we look is what can be the effect of the use of a feed additive on the performance of a farming system. So again, we have always a baseline and the feed additive scenario, and we have evaluated 3 different aspects. One aspect is the modification of the feed composition. So in that case, you see that if I give you just two equations, because this document is full of equations, I just give you here two equations, which are looking to the nitrogen. So when you modify the feed composition, you may modify the crude protein content of the feed, which is managed by the phi NC here, so which is the factor of change of the nutritional composition. And then you will reduce the nitrogen ingested. Why is nitrogen ingested important? It's because we consider that for the same animal performance, so the same production of meat, if you reduce the N ingested, you will reduce the N excreted. And the N excreted is the one which has an impact. So by calculating the impact of the N ingested, you can model, yes, the part on excretion and then the part of emissions. So this is one way of looking at it. You change the feed composition. The other way of looking at it is to look at the feed efficiency. So you improve the feed efficiency, either because you improve the performance of the animal, or you reduce the feed conversion rate. Different ways of doing it. So in that case here that I show on the slide, we have considered that we have an effect of the feed intake. So in that case, you see that the factor for feed intake is calculated here, and then we can calculate how the feed additive scenario is comparing to the baseline. So in that case, we have a feed intake has been slightly increased, so we will have a higher intake of nitrogen. And then at the end, so this is one way, and you can combine both if you wish. So in your calculation, you can always combine both. And then we could have also an impact on emission factors. Here we have the effect of example given a methane inhibitor that would reduce the emission factor of methane. And there also you could calculate the effect of the methane inhibitor on the methane emission. So all these equations are helping to model and to evaluate the mitigation options when used on the animal farm. The other thing we said is that all this should be substantiated. So it doesn't need to, so you cannot just put a figure to say I reduce the protein content by 5%. You have to document it. So the substantiation is also part of the claim that you can do on the product and your calculation. So there the set is set because we have the guidelines now and they are all available. Now, what do we do as an industry and where are we going? Because the journey is not yet finished. So we need to implement these guidelines now. We need to make them live. It's not good to have just a paper in the cupboard and never use it. So we want to use this. And for doing that, we have implemented certain elements. The first thing that we did is what we call the global database of feed ingredients. And it's under the acronym GFLI, which means Global Feed Livestock, I forgot the I, Feed Livestock Inventory, I think it is. So what did we do there? We said, if now we are able to make, if we want to be able to make the feed footprint, we need to know about the ingredients used. So in this database, we are putting secondary data, that means in bracket generic data, regarding all the products that could be used in the production of a feed. So these are agricultural products, these are processed products like soybean meal, but also manufactured products. And then under this manufactured product, you clearly see the feed additive and specialty feed ingredients are coming in that. And in order to develop this database, we said, okay, we need to develop a methodology that would be putting in practice the LEAP and the PEF requirements. Because when you see product category rules, it's not always so easy to use. So what we need is to also explain and develop a way to clearly explain to the people how they should use it. It's a kind of code of practice, if you wish, where you say, okay, this is how you should do this. When the LEAP guidelines say you should make allocation, the methodology of GFLI says that this is how in practice you should do it, so that everybody is doing the same. Again, harmonization is a key word. So the process is that we develop the methodology, which is now, you have the one of October 2020. It will be modified slightly shortly. it's not big changes, but it's adaptation, and particularly introduction of feed additives. And in order to get your product into the database, you need first to develop a project, which we call a data in project, where people meet. Then we create a data set that could be on a grain, or it could be on a chemical product. This is done on the methodology GFLI. It's reviewed, critical reviewed, and when it's critically reviewed and we have all the elements in place, then we enter the product in the database. So currently, the database is covering feed ingredients produced in Europe, Canada, and US, and we will shortly also work on other countries like Brazil. And it's also now open for feed additive. Now, for the feed additive, we needed to improve a little bit the GFLI methodology, because the GFLI methodology was very close to the PEF to say, look at the LEAP guidelines. And we consider it's not enough. We should be a little bit more precise on this. So we created, end of last year, a joint working group between GFLI, IFIF, and FEFANA. And also we have opened the potential for data in project, which will look at secondary data, for example, an average value or generic value for a phytase, but also for branded data. So a specific value for a specific phytase. So these are the two options that now are open to GFLI. And for the branded data, we are currently piloting it. So in fact, what we did in this working group, we looked at the methodology as it stands, we discussed it, and we then improved it in order to put into this methodology the information that were in the LEAP guidelines for feed additive. But as you understand properly, these guidelines only use the part on manufacturing phase, because the GFLI is a database where you could know what is the impact of a feed ingredient I use in my feed. So the only thing we looked at in these things was to look at the manufacturing process. And we try in the methodology to align all the points with the other feed ingredients. So it's a commonality of work. So this was done, and the GFLI database will be, methodology will be improved. We have also the LEAP catalog of application, where we have put the GFLI, but if you look at this, you have individual initiatives. Here I only look at the one from Canada, where they use the environmental performance of feed additive guidelines, and they measured, in fact, the impact of the feed additive on the beef production. That's where we are with the implementation. Now, what are the next steps? So for the next steps, as I've said, the guidelines for OMLIP is composed of two parts, the manufacturing part and the mitigation option evaluation part. This second part is currently under evaluation. We are discussing within IFIF and with our members how best to approach this. So what to do to make it practical and to make it available for all the members and all the users. And we are continuously contributing to the LEAP guidelines developments. For example, we have been active in the methane assessment guidelines to support also the way to measure methane and to measure its impact, you know, with the global warming potential or the global warming potential star, but it's taking the different behavior of methane compared to other greenhouse gases. So at the end of the day, what we do with a feed additive and how we want to implement it is always to look at the situation on the farm. Here I take a poultry farm, which has a feed. This is the baseline. We look at the impact on the environment using the LEAP guidelines and the PEF guidelines, and then for the feed ingredients, the GFLI methodology. And then we look at the mitigation scenario. That means we put the SFI or the specialty feed ingredient or the feed additive into the feed. And then we look at what is then the impact on the environment based on the LEAP guidelines, and soon to come, I hope, this implementation that we will put in place. So with this, in a nutshell, I have given you a flavor of what we are doing, and I thank you for your attention.
Thank you very much, Philippe. Very nice presentation. I have a look if there are questions in the chat. Just a second, because so there is one. Can you give an example of environmental impact of production and use of feed additive to show the balance to show if the balance could be positive or negative.
Can you repeat it, please? Sorry.
Can you give an example of the environmental impact of production and use of a feed additive to show if the balance could be positive or negative?
Yeah, I will not answer this question directly because I think Ermias will provide some data afterwards. It will give you some examples of what is done. But what I can say is that on all the studies that we have done so far, in most of the cases, that means 99% of the cases, we arrive to a situation where the impact of the manufacturing is well below the impact it has on the animal production. So meaning usually the impact of animal production outcompete the manufacturing process. And there are two reasons for this. The reason is that the impact is not always so big as we think. And the second thing is that they are used at very low level. So the impact in the feed is very limited. I hope this answers the question.
I think so. There is another. How does the GFLI database and by extension the LCA output account for land use change in different countries?
Mm-hmm. So that's a very interesting and important topic, because we are discussing it, to be honest. So far, land use change is part of the database. So we are calculating the impact of the feed ingredients with and without land use change, and we always calculate it like this. So we have two elements in end. Now we know that so far with a land use change, we were using a generic approach. So meaning that the land use the land is used for one crop per year and things like that. We are currently discussing because there are other ways of looking to land use change that should be more localized. And we are currently looking at this to see whether we can improve the way we are looking at land use change. There were some recent publications that we need to take into account in our discussions.
There is another, and then I have one. What would be the LEAP guideline to use when a raw material is missing in the GFLI database?
In fact, what we do there is that we try to use a similar product. So we are, if there is one product that is not in the GFLI database today, we advise to use a product which has a similar approach. So you may use surrogate, in fact. But the objective is clearly at the end that this database is as large as possible so that people don't need to do that. But we are not there yet.
Yeah, there are many questions actually are going up very fast, but I would like to ask you, are you going to consider categories of feed additives or the granularity, let me say, of your evaluation will be until, because you said before also a specific feed tails.
Yeah.
Before. So I would like to understand if your evaluation will be so fine or considering categories and so on. And second aspect is you use many times the term harmonization. Is this nowadays a limit, for instance, between Europe, just for mention two areas, Europe, US, and South America, or other places in the world?
Okay, so with regard to the first questions regarding the categories, yeah. In fact, initially the idea was to work on categories. So we have wheat from US or wheat from East Midlands, things like that. Now we have opened recently in GFLI what we call a branded data approach, which would cover any kind of ingredients, where we would have a very specific way of producing or very specific data. It will be mainly primary data, so data from the site, where you could have at the end in the GFLI database either generic approach or a very specific product. For example, you could have a wheat from the Midlands, and close to it, you could have a wheat produced with this particular agricultural practices. And then you would have to choose which is the product you use. So this enables also to have a feed chain that are more knowledgeable. So you could also say, I want to have a soya bean meal from Brazil, but that are coming from a certain region in Brazil. So at the end, you may have this kind of information. We are not there yet. We are launching the pilot. The pilot has been launched just beginning of this year. And so now we are working on it and see how this works and whether we need to implement methodology. Now, in terms of harmonization, what I meant is that we want to have an harmonization of the methodology.
Yeah, right.
So of course, the inputs are different between EU, US, and South America. Or Australia, if you wish to do that. But the methodology, the way you calculate should be exactly the same, because otherwise you don't know whether the difference is based on the inputs or whether it's based on the methodology.
Clear.
So
last question, I'm sorry for the other. From where should the magnitude of improvement in feed conversion rate should be taken when doing this type of analysis?
Well, again, Ermias will clarify this a little bit afterwards as well. But I think if you speak usual, so yeah, if you speak about usual impact, you would have something about 3 to 5% improvement in feed conversion ratio. It's already a good impact. And in fact, what we will do with mitigation options, we have two kind of products, I would say. The products which are improving the situation of the farm, so plus 3 to 5% improvement of feed conversion ratio or performance. And then you will have a mitigation impacts, and then you may have solutions that will really have a triggering effect. I am thinking potentially on methane inhibitors, where you could have an impact of 25%, and then you will see a very big impact on the end product. But I think there is no limits. The only thing that it gives you is that it gives you the opportunity to say, even if I have a 1% improvement, I calculate the value of this improvement compared to the value of my manufacturing process and impact I have on the feed composition. And then you may end up by saying, okay, it's positive. I remember in the initial SFIS, and again, I don't want to take too much on time on Ermias' presentation, but in the original thing, we said, okay, we don't improve performance. We are just using phytase and protein and amino acids, and we keep the performance unchanged. The fact that we changed the feed composition was already making an impact. So
I have to thank you again for your excellent presentation and also for this discussion. I'm sorry, we have no time for getting detailed with many other questions that we have seen in the chat. We have to move to the next presentation. Thank you again, Philippe, for your excellent work. And I hope there will be another opportunity for us to for maintain a link with also the scientific society about the progress of this work, which will be extremely useful because, of course, to get information and method also extremely important to develop methods and implement methods for such kind of measurements. It will be extremely important for the future because for what we learned during the last few years, above chemical composition and requirement, the third pillar is also this information also in the database and in the software that are going to be developed by the industry and not only. So thank you again. Shall we move to the second speaker of today? So the second speaker of today will be Ermias Kebreab. Sorry, I hope I pronounced correctly your name. Ermias is Associate Dean of Global Engagement and Director of the World Food Center at the University of California, Davis. He conducts research on impact of livestock on the environment. He is contributing author of 2019 IPCC update on enteric methane emission. He co-chaired the feed additive and methane committee of FAO. He is author or co-author of over 250 peer-reviewed articles, and he received several awards. He's a regulatory and invited speaker also in many events, including TED Talk in 2021. So the floor is yours, and the title of your presentation will be LCA Approach to Assessing the Environmental Impact of Using a Specialty Feed Ingredient in Swine and Poultry. So, Ermias, the floor is yours.
Great. Thank you very much for the kind introduction, and thank you for the invite to be able to present this to you. So I'm going to be talking about the LCA approach that was used in order to assess the environmental impact of using SFI in both swine and poultry. So the demand for protein is expected to increase in the next few decades with about by 2050, and meat, particularly poultry and swine, is projected to increase by about 73%. So in order to be able to meet that, livestock production will have to double in the next 30 years or so. However, we don't have room to expand the arable land, because what we used to do before was that when there is stress, when we need to increase productivity, we basically put more land under production, but there's no more arable land. So we will have to intensify our food production system in order to meet our the demand. So the issue now is, can we do this in a sustainable way? I think that the world's food system will be able to respond to meet the demand, this doubling of demand, but it's not going to be easy. There will be challenges to make sure that this happens in a sustainable manner. Also, it's important that this is done equitably and within our planetary boundaries. I'm sure you've seen this planetary boundaries, and in some cases, particularly in nitrogen and phosphorus load, we are basically using an equivalent of 1.3 planets. So obviously, we don't have more than one planet. So we have to make sure that we do this increasing, we meet the demand without having to overconsume outside our planetary boundary. So there are environmental impacts in pig and poultry production, and so they are mostly related to the excretion of excess nitrogen and phosphorus that will lead to eutrophication of lakes and rivers, and greenhouse gas emissions, particularly from manure management, and issues that are largely due to ammonia emissions into the atmosphere and the use of the primary energy demand as well. If you make diets with natural feedstuffs only in order to meet the animal's requirement, often it results in large excesses of amino acids, nitrogen, and because of the imbalance of essential amino acids and non-essential amino acids. There is also excess of phosphorus, particularly in the form of phytate phosphorus, which is not very digestible to non-ruminants. And feed may not be efficiently converted due to several anti-nutritive factors. So using specialty feed ingredients can reduce the impact. However, this must be done without impairing performance or also having unintended environmental consequences. So one way of doing this is then to try to use things like specialty feed ingredients like crystalline amino acids that would help us reduce nitrogen excretion by some estimates by about 8% for every 1% reduction in protein intake. So basically, because of we have a better balance of amino acids, essential and non-essential amino acids, we're able to reduce the amount of nitrogen that was given to the animals. Similarly, using phytases would also help us in terms of increasing the phosphorus retention, and so we don't need to provide as much phosphorus to the animals. Other feed ingredients include non-starch polysaccharides, because in poultry and pig diets, non-starch polysaccharides they're anti-nutritive, they're degrading very slowly. So having those enzymes will help this counteract this effect and help improve the feed conversion ratio. The use of proteases will improve protein digestibility in the diet, and so you don't need to add as much feed protein into the diet if you use those kind of enzymes. The use of probiotics help basically improve the gut health, and they help stabilize the gut microflora, so the animal is not using as much energy in order to maintain that. So it has been shown that it improves the food conversion ratio as well. Using organic acids has been shown to reduce pH in the intestine, and that helps lower the pathogen load, and also indirectly then increases the feed conversion ratio as well. Some phytogenic substances, essential oils and things like that, have also been shown to help in the stabilization of the gut microflora and reduce the mortality rates as well in poultry and pigs. So that way, if you look at for how many animals you need to produce a certain product, then the impact is going to be lower. So this project that I'm going to present today is part of the IFIF and FAFANA, or the EU Association of Specialty Feed Ingredients and their mixtures, where they brought together a consortium of international companies and associations, and basically looked into what is the impact of using specialty feed ingredients on the environment. So this is a pre-competitive space where a lot of the specialty feed ingredient manufacturers are coming together and looking into this and having an independent overview process to make sure that the LCAs are done in an impartial way. As Philippe was mentioning earlier, this was taken exactly as he mentioned, on how you develop a life cycle assessment, and then you go through the whole process. This particular was done according to international standards. So the LCA approach that's widely accepted, the ISO 14040, was used as a base for this analysis. So the goal for the LCA for this specialty feed ingredients was really is twofold. One is to analyze the cradle to farm gate. So we stopped at the farm gate level, the environmental performance of both pigs and broiler production, and then at the same time provide credible scientific evidence as well. So the first kind of phase of this was done on amino acids and phytases. So I'm not presenting that today because that has been already published, and you can find it. You can find a paper on Journal of Animal Science. Today, what I'm presenting is the next phase of that. So once we know the effect of amino acids and phytases, and when you put on top of that, so this work was done on top of already reduced environmental impact because of amino acids and phytases. Now we're looking at to assess the impact of using non-starch polysaccharide degrading enzymes, proteases, probiotics, phytogenic substances, and organic acids. And the way it was done is that we used three different regions in the world because of the way the diets are formulated. So there's a region representing North America, mostly the US and Canada, and a region representing Western Europe in most cases, and a region for Australia as well. So I'm going to focus my presentation today to the European conditions. So what was done in this analysis was for both pigs and broilers, for each of the systems, we have the baseline. So this is basically what would happen without the addition of any of those feed additives. Now, once you have the baseline, then we have one for where you add the NSPE, and then you have proteases and prebiotics and so on and so forth. So this was how it was conducted. So we have various conditions for the 2 species and the 3 regions. So this is a kind of a simplified overview of the system boundary, if you like, of where we were and how we analyzed it. So there are sort of basic systems here. There's 5 basic systems. One is the SFIS production. So the production of all the specialty feed ingredients, they will have associated emissions as well. So that needs to be taken into account. And then they need to be transported into the feed preparation place. It could be the feed mill. And then we have the base feed production. So the main ingredients for the animals. So this includes soybeans, corn, wheat, and things like that. They also need to be transported from wherever they are produced into the feed mill. And then in the feed mill, those are combined or separated. They are then transported to where the animals are. And then from that animal husbandry, there is manure management. So the manures, if they are used for base feed production, there is some credit given because of avoided emissions for fertilizer use. And then the functional unit is the 1,000 kilogram of animal weight. So 1,000 kilogram of pigs or poultry produced is the functional unit. And as you can see, there are a number of inputs into the system, and then there are outputs to the system in terms of emissions to air, soil, and water as well. So some of the things that we looked at, so these are the intermediate impact categories that we selected. So you can select a number of different impact categories, but these are the ones that we thought are much more sort of easily quantifiable and also understandable and of interest. So the first one being for climate change, the impact category would be the global warming potential, and for air, soil, and water quality, we have two impact category on eutrophication and acidification as well. And then finally, we looked at the energy and resource efficiency, looking at what was the primary energy demand. This was sort of went through by Philippe very quickly. So when we are looking at how does it impact, when you modify the feed, how does it impact? The way it's calculated is that if the feed additive, for example, like protease, reduces a feed protein content by 5% compared to the baseline, then we have this 0.95 times the feed efficiency. The baseline feed efficiency times 0.95 will give you what the reduction in crude protein, or in this case in nitrogen, would be. So we have to take into account the emissions due to the feed. And again, Philippe has shown different ways of manufacturing the feed additives. So based on how those feed additives are manufactured, that needs to be taken into account, whether it is mining, whether it is the chemical synthesis, or plant extracts. So all of that will have its own way of accounting for how much carbon dioxide, mostly in this case, how much carbon dioxide, how much water has been used in order to come up with, let's say, a kilogram of this feed additives. And so the effects that we assume, I think there was a question regarding this from the previous session, was that, what are we assuming here? For the special feed ingredients, for the non-starch polysaccharide degrading enzymes, for example, we are assuming there is an improvement of FCR by 3% for pigs and broilers. For proteases, it's actually a reduction in protein, so a reduction in soybeans and things like that. For pigs, actually, it's only at the first phase, in the weaning phase, and not in the other phases, so you don't see as much impact. But in broilers, it was on more phases than just the first one. Probiotics, we assumed FCR of about 5%. and slaughter weight improvement of 3%. The same thing for broilers, with the slaughter weight being a little bit higher. And for pathogenic substances, the reductions, you can see 2% for broilers, for pigs, and 2.5% for broilers. Organic acids about 5% for pigs, and then 2% for broilers. So these are based on published material. So this is an average sort of effects of those feed additives. But obviously, the best way is to get a primary data. So if you do have a primary data where you showed that there was an improvement in FCR or in body weight change and all that, and then you can use that information, and then you can use it, and you can look at the LCA of that impact. But this, as I said, is a pre-competitive space. It's a combination of different types of work that was published, so an average of a lot of this impact. But if you want to know more specifically, then you will have to get primary data. So the base feed composition for pigs in Europe, it looks like this. And basically, what I wanted to show here is that it doesn't really change. The only change that you see from different options here is the proteases. So when proteases were used, it's assumed that soybean meal was reduced a little slightly. Again, this is pigs, so the reduction is not that much, but that's the only change you see. The rest, the diet for the rest of the enzyme inclusion did not change. If we were to do this in amino acids, for example, then you see a big change, because for amino acids, you will then reduce the soybean meal and rapeseed meal and all that quite substantially. But because now we're already assuming that we're using amino acids, this is on top of that. So going into the results now, I'll show you some results for pigs and then one or two for broilers. So in this case, we're looking at the global warming potential. What's the effect of using the different feed additives in reducing the global warming potential? And you see there is some effect here. The NSPs would be probably the ones that have the bigger impact. Proteases did not have an impact in reducing, but others will have some reduction there. Looking at if you include the effect of land use, so land use is basically if you look at the soybean that's been imported from mostly Latin America, particularly Brazil and Argentina, there is a bigger impact of that, and then you can see that there's more reduction happening when you try to save when you include the land use change as well. For acidification potential is probably what we saw more impact, particularly using the NSP and the probiotics. We've seen a bigger impact in terms of reducing the acidification potential. For eutrophication potential, we also saw quite a bit of differences as well. The NSP and probiotics, because of the feed conversion ratio, right? So the FCR is really the main driver in this case, where there is a better FCR, you don't need as much feed. So you're saving feed, which is sort of a major source of emissions, and so or source of nitrogen and other emission as well. So because of that, the less feed you're using to make up the same product, then the better the environmental outcome is going to be. So this is just for comparison. I'll show you the broilers as well. And for the broilers, again, the diet is kept more or less the same. The only thing that really changed was on their proteases, where the soybean meal now has been reduced. So compared to pigs, this is much more reduced. Again, this is a composite base feed, right? It's not really for one phase. It's basically the different phases combined, depending on how long they're staying on that phase. So this is kind of an average base feed, and so on average, you saw that there's a reduction in soybean meal included when you add proteases. And so to show you just one example of using broilers, so for the eutrophication potential, now you can see the proteases have an impact. As sort of a bigger impact and a reduced amount of, in this case, for eutrophication as a kilogram of the phosphate equivalent per 1,000 kilogram of live weight. So just give you a summary for the broiler, you can see that the climate change metrics, or the GWP 100, has not changed a lot, particularly in organic acids. It did not change much, because in organic acids you need to give it in such high quantity. There's the impact on the manufacturing of the organic acids as well. In others, the quantities that you use are quite small, but in organic acids, they comparatively it's higher, so you wouldn't expect as much impact as well. When you add the effect of land use change, then you see even further reductions in almost all cases. The acidification potential for probiotics was the greatest. Proteases have also have a greater impact, and eutrophication potential, same thing. Proteases and probiotics and broilers have higher impacts. And for the primary energy demand, in some cases, was a little bit increased in organic acids, again because of the amount of organic acids you need to include in the diet. But in most cases, there was a little bit of reduction as well. So the key results from this work is that the supplementation of the specialty feed ingredients, both in pig and broiler diets, have shown a reduction in environmental impact when you use the functional unit, 1 ton of animal live weight produced. So the improvement here is about 3 to 5% of the 4 impact indicators. You might think that 3 to 5% is not that great, but remember, this is on top of the impact that already shown for feed additives and phytases, which was quite substantial. So we already have that reduction happening environment, and then on top of that, we have this 3 to 5% reduction happening from using the different feed ingredients as well. So supplementation with the specialty feed ingredients, and we've seen has a strong effect on both the eutrophication and acidification potentials in both species. One of the important contributors for this has been the animal feed, particularly if you change the feed efficiency, then it has quite a strong impact on the results for the environmental benefit. As I mentioned before, you really need to have a primary data, and also in a specific region, a specific feed additive to get an accurate result. So this is a sort of a general idea of the impact of those feed additives. But if you want to know what is the feed additive impact of using a certain type in a certain region, then you have to collect data from that region. What are they being fed? What diets are they being fed? And when you add those feed additives, what change are you making in the diet? And that's how you will get a much better accurate results. So there is a lot more information on this. I've condensed this. I say the report was about 150 pages, so condensed that in 20-25 minutes. But there is this resource that you can go, and hopefully this will also be published in due course. So thank you for your attention, and happy to answer any questions you may have.
So thank you very much, Ermias. You condensed really a lot of information in a very brief presentation. Thank you, because actually the information were extremely useful and effective in my personal opinion. But of course, we have some questions. The first one is the common one. What about the basal diet? So are you able to distinguish between the effect of the feed additive compare the basal diet? This is a key issue, of course, because we know very well that we can use an excellent additive in a very bad diet and observe any effect. So this is in line with a question here in the chat, is saying the comparison depends heavily on the composition of the baseline diet. For example, in the Journal of Animal Science paper for the impact of amino acid, the baseline for broiler was first limiting in methionine. This disadvantaged the performance of a baseline diet and produced favorable results for the addition of amino acid. Did the same principle apply here?
Well, so I think the first one on the amino acids and phytases was really focused on to see if you only use a natural feedstuffs, what would happen, and yeah, obviously, especially for broilers, they're not going to meet their methane requirements. But in this case, that's not the case. This is basically a well-balanced diet. So the base diet is a well-balanced diet. It was done by nutritionists from the different regions. So this is what you would normally feed. And the only thing that was done is that's basically those specialty feed ingredients were then used on top of that. Otherwise, this is a very well-balanced diet that anybody would feed.
Do you mean that the basic assumption is in presence of a well-balanced diet, we are able to mitigate the effect on the environment by 3-5% according to? Okay.
Absolutely. Yes, that's right.
Thank you very much. So there are no other questions from the chat. There is somebody who asked if we are going to send the question that we collect here to the speaker. I will try to do that via the ERP organization. They were able to send that. Well, another question from my side is, you consider several kinds of additives. I can imagine that it's not easy to rank them, but for sure, so looking to that chart, that graph that you showed to us, and also looking at different kind of feed additives, we can have an indication. So my question is, there is what about the potential of different feed additives, in your opinion, and based on your result that you partially showed today and so on? Could you recommend or give an indication without compromise any market, of course? And but as a scientist, we have seen that working with probiotics, working with phytase, working with protease, and so on, we can got different scenarios. And also, what is surprised for me is that actually also the manure management is effectively affected by, of course, by this the use of this material in the diet.
Yeah, so I think the main thing here really is we will need, if you wanted to have a more accurate data, we really need to have a sort of a primary data on specific feed additives. I think this is really setting the scene of showing that using those are feed additives, how impactful they are for the environment. It's basically to try to draw a line, basically to demonstrate that by improving the feed conversion efficiency, this is the benefit that we can get. So I think at this point, it's the whole industry basically trying to show what impact it will have, right? But if you wanted to see specific ones, then unfortunately we're going to need a specific data for that as well.
But in such kind of analysis, can we assume also that at the same feed conversion rate, if we got a reduction in the emission, whatever it is a success? So in such kind of evaluation, we can get also an improvement just for the environment, because maybe we reach so high level of performance in such kind of animal. Of course, we look for improved further, but maybe we have a scenarios in a farm very well managed and so on, in which actually we are already on the top or in a flat.
Yeah.
So I would like to know, in such kind of calculation, also just the environmental effect is a positive result or is a no results?
Yeah, no, I think it is a positive result, you know, for the environment. I mean, if you look at how things have been produced in elsewhere, it's already up there. I mean, we just now looking at the small advances that we're making. Otherwise, you know, the big leaps have been done, and I think we want to tell the story. You know, so the leap in sustainability that has been gained is quite tremendous, and then we are still pushing the envelope and going even further.
The last question: what level of evidence would we require for mitigation effect of an additive? Example given: if an additive has carbon trust certification, sorry because it's moving. Is this sufficient, or will there be some new committee to examine and confirm this effect? Quite complicated question, but are you able to see in the chat?
Yeah. So I think it's basically, you know, to try to figure out what the effect is going to be and how to decide whether that effect is significant or not. I think what we do is the best recommended way is to have at least like 3 or 4 studies that was done on that, and having a kind of a meta-analysis conducted on that. So a meta-analysis will actually give you an idea of how effective that is and under what conditions it's going to be effective. So most protocols would actually call out for having a meta-analysis conducted on that particular feed additive to get an idea under what conditions it works well, under what conditions it doesn't, and you know, what are the factors, you know, it could be dietary factors that are affecting the feed additive as well. So the best way is to really have a meta-analysis conducted before you do an LCA.
Thank you very much, Ermias. We are late as always. The topics are extremely interesting, and the people ask so many questions. I hope will be the opportunity to give an answer also by email or whatever.
Yeah.
Thank you again. There is a short coffee break. I have to make it shorten, so let me say 10 minutes maximum, and we will be back with the last speaker. I hope the people will stay online for the last speaker from DSM. So enjoy the coffee. See you later. Okay. So 1 minute to be perfect. Okay, so we are approaching to the last presentation of today from Nicola Walker. Nicola is the principal scientist on DSM, the Clean Cow project, investigating the mode of action of and the effect of free nitrooxypropanol as a methane mitigation in ruminant trials. She is an experienced ruminant microbiologist and nutritionist working in academia and industry. She has investigated a range of different feed additives from their impact on the rumen microbial ecosystem and host animal in terms of health, production, and on the environment with respect to reducing methane nitrogen extraction. The title of the presentation will be a non-exhaustive literature overview on additive use for mitigating methane nitrogen emission in livestock farming. Please, Nicola, the floor is yours.
Thank you very much for the introduction, Luciano. If you have any issues hearing me or seeing my screen, please let me know. I am in home office and sometimes the internet is not so kind to me here. I'd also like to thank the organizers, the EAAP and FAFANA, for inviting me today to give you a quick talk on some of the different additives that are used for reducing methane emissions, particularly from ruminants, and on nitrogen emissions within monogastrics. And Ermias touched on this, we really have to operate within the animal planetary boundaries, and we really need to focus not only on greenhouse gas emissions, and so in terms of both CO2, methane and nitrous oxide, but also in terms of nitrogen and phosphorus flows. We really have to start doing something to try to reduce the carbon footprint of livestock production. If we actually look in terms of human activities, they're a main driver for climate change. However, livestock production also plays a significant role. And if we look in terms of the livestock production itself, 14.5% of greenhouse gases actually originate from the livestock sector. And as a ruminant scientist, I'm sorry to say the majority of that is actually coming from both beef and dairy cattle production. Thus, the cow hoof print actually presents a very major challenge. When we look in terms of tackling greenhouse gas emissions, we should not just focus on methane, but also on nitrous oxide as well. In terms of enteric methane, this is mainly coming from ruminants, with very little methane coming from manure storage, and nitrous oxide from manure storage is also minimal when you compare with monogastrics. Our main interest in terms of methane is that it has, of course, 28 times global warming potential of CO2. It's relatively short-lived, so anything that we can do to mitigate or reduce methane emissions can actually have quite a significant impact on the carbon footprint. In terms of nitrous oxide, this is probably more potent. It has 265 times the GWP of CO2. And as you can see from this diagram here, it's really within the monogastric that we see this problem of methane coming from pigs and nitrous oxide coming from pigs as well. But then when we look at the poultry, they are the biggest contributor in terms of nitrous oxide emissions compared to the relative percentage of impact on the footprint. And when we look in terms of species and their actual proportion of impact that they have, as I said, cattle have by far the very largest footprints. But as a consequence, they can actually have the potential to have the greatest impact if successful mitigation strategies are implemented. Now, this diagram I've taken from the GLEAM actually is just showing the potential of those mitigation strategies. And this is looking just solely on the principle of implementing a strategy whereby the practices of the top 10th percentile of producers within a specific region, if other producers in that region implemented some of the approaches that they were taking into consideration, and that they could achieve, this is the type of reduction that could be potentially achieved here. And this is without even taking into consideration the use of differences in diet formulation, management practices, maybe even the addition of additional feed additives. One of the pieces of work that I've been involved in recently within part of the role working with FAFANA is to look at the PEF agri modeling within the PEF tab working group and within milestone 3. This was set up, Philippe touched on this earlier, just with regards to looking at the environmental footprint, so the product environmental footprint of the PEF, and different applications that can be used. This is trying to link in with the FAO LEAP findings, and also with the most recently published TAG guidelines as well. So there was a set of experts within the set up within the EU Commission. And these were used to identify that some agricultural practices were not sufficiently modeled to be able to propose a proper farm footprinting. Within this workstream 3 was set up really to focus on the input of the flows of direct emissions related to feed digestion and manure management. And as a key part of that, it was to investigate enteric methane related to feed digestion, nitrogen emissions related to animal feeding, and emissions related to animal manure model management. Just as a short scenario, the main point as related to my talk here is that this is just will soon be published, and it's taking into consideration different guidelines that will be used within the new PEF. In terms of recommendation, it's split into 6 different subtopics, the first one being enteric methane emissions. And in terms of the recommendation for PEF studies for dairy cattle, the recommendation is to use the formula from New et al., which was published in 2018, which takes into consideration for estimating your baseline methane emission in terms of grams per animal per day, that you should take into consideration both dry matter intake and also NDF concentration as a percentage in dry matter as one of the best or better approaches. For other types of production, either using a tier 2 approach and using lookup tables as published through the IPCC in 2019 to achieve exact methane conversion approaches, or for certain countries where they're going to use a tier 1 approach to use a lookup table 10.1. For certain countries, of course, they're much more complex, the models that they're using. They're going towards more tier 3 approach, and where they will be looking at country-specific methods for estimating enteric methane emissions, and these are the ones that will hold for that particular country. With regards to methane inhibitors, very much so, as Philippe touched on this earlier, the FAO LEAP feed additive guidelines will be recommended in terms of assessing the impact that a feed additive may have on reducing methane. And for the baseline, it will use the recommendations to use the new model. On the subtopic 2, which is methane emission from manure storage, this will use the default method from IPCC that was updated in 2019. And for nitrous oxide emitted to air from manure storage, this will also be based on IPCC. In terms of ammonia, nitric oxide emitted to air from manure management, the recommendation from the PEF is to look in terms of using the default method as previously published by EEA in 2019, which is a tier 2 approach. But in terms of for fattening pigs, it's most important to take into consideration the tan content in manure. And this is modeled by the formula developed by Capelier et al. In 2021. For other mammals, the tan content will be modeled using the DAM, Jen, and Hutchings from 2008. When it comes to feed additives with a direct effect on ammonia emissions, these will again be closely associated and following the FAO LEAP guidelines that Philippe touched on earlier, and the requirements that we put in place. If you can keep these points in mind when we go into discussing the actual different feed additives and the impact that they can have both on methane and nitrogen emissions. Other parts of subtopic 5 are of course on non-methane volatile solids, and also in terms of trying to credit the farm for the use of anaerobic digestion on the farm itself. So when we come to look at ruminant enteric methane emissions, for those of you not so familiar with ruminants, the reason that methane is formed, it's a result as an end product of fermentation. It's as a result of the feed being broken down within the rumen by the different microbes, and the CO2 and hydrogen that's formed from fermentation is then captured by the methanogens and converted into methane. And a nice easy way to remember how much a cow will actually produce is around about 500 litres per day around about 450 grams of methane per day for a high producing dairy cow, with 95% being eructated or burped out, with only 5% coming out from hindgut fermentation. So anything that we can add to the rumen, especially in the form of a feed additive, can have a quite significant impact on enteric methane emissions. When it comes to quantifying methane emissions, there's a range of different methodologies that can be used. We can use either measured data, which is using direct measurements. We can use different equations, as I've touched on previously on the new model that was produced by the Global Research Alliance, where they're taking into account the impact of dry matter intake and NDF or fiber within the diet. There's more mechanistic models. So when you go to the Netherlands, for instance, they have implemented the Kringlet visor, which is taking more into account the use of feed dietary tables and modeling how diet can have an impact on methane output. Or it can be a mix of all of the above. We find that there's a comparison between national inventory, which tends to be a fairly basic approach, which is more or less one size fits all, or, as I said, the more specific, more advanced, more complicated models, which are used as a farm accounting tool, which are very specific to the farm itself. And that way, if you can implement that, then the use of a feed additive can be taken into greater consideration. The farmer can have greater credits, perhaps, for actually taking a positive stance to try to reduce his methane emissions. So in terms of the different methane mitigation strategies that we have available, there are a range of, if we went for animal or feed management, there is, of course, the use of different dietary strategies, trying to improve feed efficiency, animal health, trying to look at ways to improve pasture management, maybe with some supplemental feeding. These type of approaches will give you between 5 to 10% improvement or reduction in your methane output. Diet formulation as well can be critical. We tend to find that methane emissions will be reduced on a higher concentrate diet. There can also be the use of both oils and fats within the diet. The reason the fats can have some impact is that it will have a reduce maybe the fiber digestion, and as a consequence, we can find that not so much methane is produced itself. Potential of using more protein feeds, toniferous forages, etc., etc. But really today I'd like to focus on rumen manipulation and the use of specific additives. The ones I've highlighted in bold are the ones that we'll really focus on for today. There is a large range of different additives that are out there, but in terms of really things that can have a major effect, then we have to really look at additives that can directly impact the methanogens themselves. Perhaps one of the most widely researched is 3-nitroxypropanol. The good news for this, it's the first feed additive that's been approved within the EU under EFSA category 4C, so a zootechnical feed additive that has a positive effect on their environment. The recommended dose rate is between 60 to 91 milligram per kilogram of total dry matter intake of the active form of 3-NOP. The EFSA feed panel have concluded the product's efficacious. It's safe for the animal, safe for the worker, safe for the consumer, and also safe for the environment. We don't find any 3-NOP being excreted out in the manure. Pretty much it's widely researched. There's more than 50 peer-reviewed papers. It works in every type of ruminant where methane emissions have been, there's been a large number of studies where methane emissions have been measured directly. In terms of efficacy, up to 90% reduction in methane emissions have been observed. That's on a finishing cattle diet. We do find that when you use a high starch diet, that the methane reductions that can be achieved are far greater. That's the case with the majority of different additives. When you're looking at dairy cows, within that recommended dose range, we've seen up to 46% reduction of methane. The target itself is very highly specific. It's the methyl coenzyme reductase enzyme, which is involved in the final step of methanogenesis. And what happens here is the 3-NOP. It's a structural analog of the substrate for that particular enzyme. And what happens is it binds to the enzyme. It activates MCR, the enzyme itself, by oxidizing the active site into a nickel +1 in cofactor F430. Additionally, it's almost like there's a second effect, an additive effect in the formation of the nitrite is then reduced to nitrite as well. The mode of action has been fully published. In terms of the effects, they're fully reversible. So as soon as you stop feeding 3-NOP, then methane emissions will go back to what they were as a baseline. The LCA, as both Ermias and Philippe discussed earlier, has been fully assessed and is published. The actual production of 3-NOP has very little impact in terms of the footprint, or LCA. In terms of effects, Ermias also suggested that ideally you should have a meta-analysis. For the use of 3-NOP, there have been at least 4 different meta-analyses published. There was one published by Dijkstra in 2018, which discussed the fact that the effects on terms of methane mitigation with 3-NOP are both dose dependent. It's a linear effect and is affected by the percentage of NDF in the diet. That particular meta-analysis is currently just being updated, and there will be a new model which will be produced in that. But one of the latest models that have been produced by Honen et al. In 2021, for dairy, we're saying about a 38% reduction for methane, and for beef, about 26%. Just to let you know, the beef is covering both backgrounding beef and also high grain finishing beef. As I said, if you've got more grain in the diet, you will see greater effects. In terms of the type of methane reduction, you'll see in terms of the graph here, this is some of the studies that have been conducted between the recommended, within the recommended dose rate, that are ranging between 15 to 42% reduction, giving an average reduction of 32% overall. What that means in terms of CO2 savings is for a cow that's consuming about 25 kilograms of dry matter intake, we're going to save about 1.3 tons of CO2 a year. For beef, the intakes are a little lower. The methane output itself in a beef animal is lower as well. And the type of saving that we expect to see there would be around about a 0.6 tons of CO2 saved per year. In terms of methane reduction, you can see anything between 0 to 90% methane reduction from a dose of 50 to 250 milligrams of 3-NOP per kilogram dry matter. So the recommended dose generally is sitting around about 100 milligrams per kilogram dry matter for the beef. If we look in terms of one of the questions that's normally raised is, what are the impacts of diet? Is there any other impacts on diet on any methane mitigator? Some of the data, this paper most recently published, just come out in Journal Dairy Science from the University of Wageningen. Here you can see 3 different diets with differing concentrations of grass and maize silage. So using a typical ration in the northwest of the Netherlands, which is mainly grass silage based, so 70% grass silage, 30% concentrate, you find between a 27% to 29% reduction, with the lower percentage reduction at the minimum recommended dose. In this particular study, NDF was fixed with starch level increasing. As we increase the starch, you can see a greater impact in terms of the methane reduction that's achievable, going up to a 40% reduction in terms of methane yield when maize silage is 56% of the diet. We've also seen some positive effects when 3-NOP is combined with a blend of essential oils. That's maybe answers the question, I think, on whether additive effects could be observed. Yes, you can see additive effects. In this case, we got an additional 7% on top of the 28% reduction achieved with 3-NOP alone, with the inclusion of a blend of essential oils. Similarly, in Canada with feedlot cattle, inclusion of canola oil also had an impact as well. And unfortunately, it's not quite 1 + 1 = 2 or 1 + 1 = 3. It's more like 1 + 1 = 1.8, with only a 51% reduction with using the two combined. 31.6% with 3-NOP alone, 27% with the oil. So there is the potential to see some positive interactions with methane mitigators in diets, and the potential to see some different additive effects observed. One of the other prominent or new methane inhibitors which is coming forward within the literature is, of course, the red seaweed, Asparagopsis. These really have an impact because they contain halogenated compounds such as bromoform, bromochloromethane, and dichlorobromomethane. In terms of the publications, they're increasing rapidly with time. We're probably around about 10 publications compared to the over 50 with 3-NOP. The mode of action is very much linked to the bromoform itself. These analogues, as you can see, are very similar in structure to methane. They react with a vitamin B12 to block cobamide-dependent methyl transfer into mercaptoethanol sulfonate, or coenzyme M. And it then interferes with that last step of methanogenesis. In terms of efficacy, very high. You've seen published data from between 98% reduction across all ruminants. A dose dependency is observed. Recommended dose is not to exceed 1% inclusion in dairy, and this is due to reduction in dry matter intake, reducing milk yield in dairy animals. Again, similarly to 3-NOP, greater reductions observed in a high starch diet. The safety still has to be fully elucidated. Bromoform, unfortunately, is classed as group B2 probable human carcinogen. Initial studies, however, shown bromoform was not detected in meat, fat, organs, or feces from sheep and beef cattle. However, iodine has been reported. The transfer of bromoform in milk appears to be dose and animal day dependent. There was a study carried out in the Netherlands which found at very high doses of feeding the seaweed, there were some problems with the dry matter intake reductions, significant dry matter intake reductions, and also seeing some bromoform in the milk. Iodine and bromide have also been shown to be accumulated in milk in another study conducted in the US. And in some instances, ruminal mucosa have also been affected. The full ADME, so it's absorption, digestion, metabolism, excretion, still has to be published. The worker, consumer, and environmental safety still also have to be published too. The life cycle assessment is still to be fully assessed, and this will probably have to wait until commercial outputs in full operation due to following the scale up. Due to the transport, it's fed as a freeze-dried or dried material. These will have to also be taken into consideration. Another feed additive is, of course, nitrate. Mode of action is such that it is an electron acceptor, so it draws electrons away from methanogenesis. It is perhaps, in terms of efficacy, a recent meta-analysis has been published, also by Marius's lab, showing a mean dose of 16.7 grams of sodium nitrate could decrease methane production by about 13.9% on average, depending on dose and type. Also, there are some differences between dairy and beef. Safety, there's some concerns of potential nitrate toxicity There's a requirement to adapt the animal to increase dose. And at very high levels, there's been some concerns of methyl hemoglobin transfer in milk. The LCA has also been completed for this particular additive. In terms of phytogenic substances, we'll start with the essential oils. These are volatile lipophilic plant secondary metabolites. There's a lot of publications, many of them in vitro, many of them where methane's not been measured. On a recent assessment from Hegarty et al. In 2021, there's been less than 10 in vivo. That's related to specific blends, okay? The mode of action, wide range of antimicrobial activities, inhibits the selected amount of gram-positive organisms, inhibits hyperammonia producing microorganisms, can reduce excessive proteolysis, and as a subsequent effect of that, reduce nitrogen excretion. It has an impact on the protozoa, so it will reduce nitrogen recycling. Some oils, they can have an impact on the rumicocci, so as a result, reduce feed digestibility, especially on fiber. That might explain some of the impacts in terms of reducing methane. But a benefit of this particular additive is there's an impact not just in terms of methane, but also the potential to decrease nitrogen emissions because of that effect on the hyperammonia producers. In terms of efficacy, methane reduction can be a variable and can be dependent on the blend and dose used. There's a range of different commercial blends have been evaluated in vivo, and the main compounds are either thymol or carvacrol, garlic or citrus, coriander, eugenol, journal, acetate, geraniol, oregano, or thymol, eugenol, and limonene blend. A meta-analysis conducted by Blanche et al. Has concluded that blend of essential oils of 1 gram per day could reduce methane yield by about 10%. Safety aspects of food feed ingredients, they're used as palatants, they're considered safe. There is the potential, I mean, these essential oils give the smell of plants, potential of milk taint at very high doses with certain compounds, but doesn't fall across all of the different compounds. We have saponins as well. These are also phytogenic substances, plant extracts. Many in vitro and in vivo studies, there's a few limited to where methane's been measured directly. It really has an anti-methanogenic effect, mainly because they're anti-protozoal. And I've just put a little picture there of a protozoa. You can see the methanogens there on the underbelly. And basically, by removing protozoa, you can have an impact on methane. In terms of the mitigation perspective, they can be variable depending on the saponin that's used, the dose, the type of diet, and there is also potential for adaptation long term. Normally, these are the tea saponins, Quiaja, yucca plant. There's also some saponins found in lucerne and Cispania cispan. In terms of recent meta-analysis, they've reported a significant 8.6% reduction in methane yield for doses of less than 0.5% saponin. However, another publication in 2021 has highlighted again, there is some degree of variability. With regard to safety, regarded as plant extracts pose no risk to safety of animal products for human consumption. However, some saponins, particularly those that are steroidal based, could be toxic to animals and may cause some fluid sensitization and issues with liver and kidney. In terms of the tannins, these also are plant secondary compounds. They're rich in phenols and have a strong tendency to bind to proteins, either existing as either condensed or hydrolyzable tannins. Many in vitro and in vivo studies, not so many where they've measured methane direct. It's really acting as a rumen microbiome modifier. Several mechanisms have been proposed, either through direct inhibition of the methanogens or protozoa, decreasing hydrogen production, through inhibition of fibrolytic bacteria and fiber digestibility, acting as an alternative hydrogen sink. And another potential benefit, of course, is an effect on reducing nitrogen emissions. In terms of efficacy for methane, variable, dependent on plant source, structural complexity, and low size of molecular weight, dose, type of basal diet, and the ruminant species. The commonly studied extracts are those from acacia, serratia, quebracho, and also chestnut, and in combination with quebracho. The decrease in methane emissions have been ranging from 6 to 45% and have been involved in both forage and concentrate-based diet. However, on one hand, they're really efficacious or appear to be efficacious, and others, there's no reported effect. So it really has to be, that a specific group or blend is used and used consecutively and consistently. From a safety aspect, plant extract may have some anti-nutritive effects in the animal with some decrease in dry matter intake or milk yield, again, dependent on dose and type of extract used. Quick summary, I won't go into this in any great detail, but very much, the potential is there for a range of different feed additives that can have very positive effects in terms of reducing methane. Moving to targeting nitrogen emissions, Ermias touched on this earlier. Essentially, there are 3 different areas which can be targeted by the use of feed additives. I'm focusing solely here on monogastrics to try to reduce that nitrous oxide. In terms of diet and digestion, there's the potential to reduce crude protein in the diet, for the fiber levels to include some exogenous enzymes. In terms of the microbiome itself, certain additives to target or modulate the microbiota within the gut has been shown to have some impact, not just in terms of improving feed efficiency or just overall gut health, but altering as well some of the nitrogen pathways. And then, of course, looking at the manure, there are some feed additives you can give to the animal which actually have a consequence at the manure that's coming out the back end of the animal. From these, looking in terms of altering acidification of the manure itself, or reducing the amount of nutrients that are excreted into the manure. In terms of specific additives to target the diet and digestibility or improving feed efficiency within monogastrics, as I said, the potential to lower crude protein levels to less than 14% as long as essential amino acids are supplied. There's the potential, of course, with what I would call traditional feed additives that Ermias discussed with the exogenous feed enzymes, so the use of NSPases, the use of phytases, amylases, and proteases, the use of organic acids, phytogenic compounds, and all of these are commercially available today, but really are only now being looked at the impact that they can have on nitrogen emissions and what's happening in the manure. In terms of modulating microbiome, as I said, there's the potential there to reduce nitrogen excretion. These are the traditional type of eubiotics, so probiotics, prebiotics. Perhaps most interesting is new precision glycans, which are coming to the market, which are shown to specifically modulate the gut microbiome, leading to improved performance, health, but which also seem to impact on nitrogen pathways within the gut as well, which have an impact on the nitrogen excretion levels. Again, exactly like we saw with the ruminants for reducing methane, phytogenic compounds such as essential oils, saponins, and tannins also can have an effect. In terms of additives to actually impact on the manure, there are specific urease and nitrification inhibitors that can be applied directly to the manure itself. There's a range of physical additives, such as biochar, zeolite, even tannins, activated charcoal, etc., that can be added to the manure and can reduce some of the greenhouse gas emissions from the manure itself. The use of yucca has been shown to act to reduce odors, surfactants, and I guess one of the ones feeding organic acids such as benzoic acid have been shown to acidify urine and reduce ammonia losses. So just to conclude, there are a range of different feed additives and specialty feed ingredients that have been identified that can have a significant impact on reducing methane emissions from ruminants. Some of these also have the co-benefit of reducing nitrogen emissions. When we look at the reduction of nitrogen emissions from monogastrics, exactly as Ermias touched on, we're gaining maybe between 2 to 5% improvement of feed conversion rates with these additives, so technical additives that have been used traditionally. They're now seeing some improvements also on the manure and nitrogen emissions from there. In terms of targeting or improving feed digestibility, improving feed efficiency, and modulating the gut microbiome, I think there is the potential to really have quite a large impact on what is happening with livestock production. I'd just like to thank you there. It's a very quick run through. But yes, thank you for your attention. And thank you for the opportunity for talking with you today.
Thank you, Nicola. It was a pleasure for us host you today and to learn so much about what you told until now to us. There are a few questions in the chat for you. The first one is about the dosage of essential oil blend with free NOP in Thomas Tsai et al. Study. It's a very specific question. And the second one is about.
So for the combination, this was using 1 gram per day of the essential oils in conjunction with a 60 milligram per kilogram dry matter of the 3-NOP. And I think, unfortunately, we weren't able to run the study. We didn't have enough cows to do the essential oils on their own, because that would have made a very nice comparison. But I think with it was around about that additional 7% is in keeping with what would be expected with a blend of essential oils. So in terms of that additional reduction, it did seem to be quite a positive interaction. I think in the end, if we start looking at combinations and using different feed additives in combination, I think this will give us the potential to really get towards carbon neutrality and have big impacts on methane emissions. We'll have to take some care though. It seems to be you can really reduce methane in feedlot cattle to very high levels, 90%, no problem. Dairy cows, I think because there's so much fiber in the diet, you've really got to be a bit more careful. It doesn't seem you can push that limit, that methane reduction as high in the dairy cow. And I think a lot of that is because of the dependency on fiber digestion.
Thank you. The second one is, what about ozone depletion potentially induced by halogenated compounds? Ozone.
So in terms of so at the moment you cannot feed halogenated compounds on their own. So this is you're not allowed to feed bromoform or chloroform or dichloromethane directly to an additive. It has to be, it's just not allowed at the moment. I think once the safety has been fully evaluated and assessed, that may open up the opportunity, I guess, for some of these other halogenated compounds to be used. For the moment, work that's been done with chloroform or bromochloromethane or dichloromethane have been really just done in a scientific setting.
I have a question from my side. Also in your previous answer, but also during the presentation, and also from the previous speaker, several times we heard the term blend or to mix up different different additives which can have different potential and so on. But when we talk about a blend of or a composite additive which include different material, we have two aspects that we have to consider: the balance between them, and of course, when you mention a blend, do you think it is important to mix up each one together or buy directly an additive which include different kind of material? I don't know if it's clear, the question. So because when we talk about blend, we can consider different kind. So I go to DSM and another company, I buy NOP from you and another for nitrogen from another company and so on. Or we can buy a already complete, let me say, additive which include different material. So which is the way, also from an industrial point of view, which will be the future? Work with a different ingredient which need to be mixed up somewhere, or it will be to buy directly a blend of materials?
I think at the moment, I mean, when I talked about blends, these were essential oils, you know, or some of these plant extracts, which normally come commercially already blended from the producer. When it comes to reaching targets, there, you know, we get asked this a lot. What would be the benefit or the impact if you use, for instance, 3-NOP with another compound? And for me, I would say, you know, our data is already showing you cannot just go, I'm going to get 30% here and I'm going to get 10% there and get 40% reduction. It doesn't work that way. It does seem to be, you know, I think if you took combinations which the mode of action is quite different, then you might have a, you know, maybe a greater chance of having that more additive effect. When you come for really trying to push, you know, it is going to be a little bit more difficult. Who's going to supply that? I guess, you know, a lot of the feed mills, people like this, you know, they source their ingredients from different places. The only thing I would say is, you know, in terms of accounting for it, I don't think you're going to be able to do this. I'm using this one, so I can claim, you know, 30% from here and 20% because it's proven there. You're going to have to, someone's going to have to do that interaction and test it. You know, we've done this work looking at certain additives just to check for this positive effect, a neutral effect. And, you know, we've tested that both in vitro, we've tested it in vivo. You know, we have some indication. But, you know, to get that accreditation to go back and say, okay, this is what's happening, then I think it's got to be tested. They've got to be tested together to give you a really accurate reduction potential.
So thank you very much also for this last answer. We lost a few participants. Of course, we are late. It was my fault probably. But the question and the presentation were so nice and, in my opinion, extremely interesting. I just received also a few emails from the audience, not only the chat, saying that it was a real excellent event. So I would like to thank again all the speakers because they gave us a lot of information from the academia, but until the industry tomorrow can work on for the, let me say, 10 years from now. So what you told us, in my opinion, is essential for look forward in the future. We are complaining nowadays with so many problems, starting from problem in getting commodities until the movement of them and so on. So it is essential to talk again and deeply about sustainability and how to sustain also our livestock system in Europe and in the world. Therefore, it is essential for me to continue in this direction. And as a scientist, I hope there will be further opportunity to address such topic altogether in order to sustain livestock in general, which is essential, important, not only for producing food, but they have also some social, more than one social effect and relevance.